Okay, so when you left here yesterday, I left you, give you a worksheet to work on. We want to go over that today. First problem, we're looking at, we want to find the radius of an arc and the volume of the block that it's taken out of. Let's just do a rough sketch here. Pretend this looks like your sheet. Close enough. Anyway, our dimensions, this is 24 millimeters wide and 8 millimeters deep. So the first thing we want to find is we want to find the radius of that circle. So I'm going to draw my circle out here. Pretend that's round. I'm going to cut this. This is 8 millimeters here, and I'm going to cut this into 12 and 12. And of course, then we're going to extend this up. So we're going to first find this distance x. How do we find it? Not plus. 12 times 12 equals 8 times x. So 12 times 12 is 144. Divided by 8 is... How about 18? So x equals 18. Which means the diameter of this circle is 18 plus 8 is 26. So the radius is 13. So now that we have that the radius is 13, there's part of our question. The next thing to find is what is the volume of the block? Well, the volume of the whole block, we have 30 millimeters here, 72, and 96. So we can find the volume of the whole block very simply by length times width times height. So 96 times 30 times 72, which is 207,360 millimeters cubed. But that is including this little arced groove that has been taken out. So we've got to find the volume of that arced groove. To find that, we've got to find the area of this segment of a circle. So to do that, we're going to look at this sector. We know since the radius is 13, we know that this length here is 5. Just 13 minus the 8. So we've got 12 and 5. I'm going to find this angle right here, which is going to be the inverse tangent. Which number goes on top, 12 or 5?
5.
12. Opposite over adjacent. The 5 is the adjacent, the 12 is the opposite. Yeah, it's okay. We'll forgive you this time, Cody. So 67.38 degrees. And of course, what we really want is double that because we want the whole angle for the whole sector. So times 2, you get 134.76. Well, why do we give a crap about that? Because that's going to help us find the area of this whole sector. The area of the whole circle is going to be pi times the radius of 13 squared, otherwise known as, oops, that didn't work, 3.14 times 169 is 13 squared, 530.66. So then the area of the sector is that area times our angle of 134.76 over 360. It's our fraction of the whole circle. So times 134.76 divided by 360. 198.64. And that is millimeters squared yet. That's the whole sector. So we still have to subtract out this triangle here. Well, this triangle is 24 by 5, then divide by 2. So the area of our triangle is going to be 60 millimeters squared. So we're going to subtract to get 138.64 millimeters squared is the area of this segment of a circle. And of course, we've learned a long time ago, like last semester, that a volume is nothing more than an area times a distance. So we're going to multiply that by the 72 millimeters across that groove. So our volume is 138.64 millimeters squared times, what was that, 72? Yeah. 72 millimeters minus 60 times 72. Giving us 9,982.35 millimeters cubed. So that has to be subtracted from this. So 207,360 minus that previous answer. We will get 197,370. We're just going to call it 197,378. Millimeters cubed. You could leave it like that, or you could take it down to centimeters cubed. Remember, one spot on the chart, since these are cubed, would be 3 spots for the decimal. That'd be 197.4 centimeters cubed about. Just to review. How many of you came up with that for the first problem?
I did when we went through it.
When we went through it? You kept up with me as I did it?
Yeah.
It's a start. Okay, well, next problem. Only got in 7 of your 12 naps for the day yesterday?
Take naps during lunch, and I walked in, and I go, oh, I'm a little tired from that nap. I just stuck in Cody's like, oh, it must be nice. Must be nice to be able to just nap and come back.
So for one like this, remember the big thing is this is your radius. You know, this is a 88 diameter, so 44 radius. This was 40 across here, so we're going to cut this to 20. And then you can find this angle here. This is the right angle. You can find this angle, which will be the same as this one. And now you know this angle for your sector. You've got the area of a rectangle, area of a triangle. You're in good shape, right? You'll know you can find this distance here and this distance here. Add that to this one and add it to a radius here and here to get the full length. Pretty simple. We've done a couple of examples like that in class already, so I'm not going to overkill that one. So let's go on to number 3. You soaking this all in, Carson? No. So anyway, this is a right angle. This is angle A is one of the things we're going to be looking for. This is 36 millimeters out here. 64 millimeters on the tangent to the point of tangency. So we know that if we draw a radius down, this is a right angle. This is going to be a 34 millimeter radius. This here will be a right angle, again on a 34 millimeter radius. That's all the information we're given. We're asked to find x here. So, what are we going to do? Well, we've got some options. Got to find some angles. It'd be nice if we could find this angle here, we'd be in the money, but can we find that angle?
No, but, no, never mind.
Never mind. That was very profound, Cody. So, where do we start? Any suggestions?
We draw a line from the center of the circle over to angle A. We have 2 sides of our right.
Okay, so if we draw that line across there, we have 34 here We don't know this yet, but we could find it, right? Because what we have is we can go across here. This will be 2 millimeters, and this will be 64 right here, right? Does that make see what I'm saying? So we could find this length. How do we get that length? Well, that's the square root of 2 squared plus 64 squared. Whoops, clear that out. Which will only be slightly larger than 64, but we do have to account for it. 64.03 to be exact. Millimeters there. Now we can find our distance x up here, which is just going to be that squared minus the 34 squared. Because the 64.03 is the hypotenuse. So that gives us 54.26 for x. So we've got x. That was pretty easy. Now to find some areas. Well, we know that this is a right angle here. And we can find this is a rectangle, this is a right triangle, this is a right triangle. We can find those 3 areas. We need to find this sector over here, and to find that sector we have to know this angle. Well, we know that this is a 90-degree angle here. We can find this angle here because that angle, this one here, this is 64 and this is 2, is going to be the inverse tangent of, which one goes on top? Cody, say 2. 2, yeah. So, inverse tangent of 2 divided by 64. 1.79 degrees. And then this angle up here, we have 34 here, and this was 54.26. So this angle is going to be the inverse tangent of, perfect, 54.26 over 34. Second tangent, 54.26 divided by 34. 57.93. So we have 57.93 degrees, 1.79 degrees, and 90 degrees. We're going to add those up and subtract from 360. It'll give us this angle. And now we've just got that sector of a circle with that angle. This triangle here, we've got the 34 times the 54.26 divided by 2. This triangle here, 2 times 64 divided by 2. And then we've got a 34 by 64 rectangle. What do you think?
I think we were supposed to find A.
We got to find angle A. Angle A you could find really quickly right now because you know this angle and this angle. You can find those easy enough. Now the good news is that was our last homework assignment for this unit. No more of these complex trig problems. The bad news is you're going to get a quiz. A quiz. Well, kind of like a unit quiz. But the good news is your quiz will look a lot like this worksheet.
Exactly.